This video is the beginning of JEST PYQ solution series on quantum mechanics. In this part, we focus on questions where we are asked to find the expectation value of momentum for a given wave function. So in this question, which is from JEST 2013, we are given a wave function psi. We are given a wave function psi of x, and its expectation value of momentum corresponding to this wave function is p expectation value. Now we are asked to find the expectation value of a modified wave function psi prime, where psi prime is equal to e raised to I kx upon h cross into psi of x. So expectation value of momentum, expectation value of p is equal to, for the first wave function psi of x, is equal to integral psi star p operator psi dx. This is the definition in one dimension. So this is equal to integral psi star minus I h cross del by del x psi dx. P prime expectation value, this is equal to integral psi prime star minus I h cross del by del x psi prime dx. Let's first calculate del psi prime upon del x, which will be necessary because we need to substitute it here in this equation. So psi prime is e raised to I kx upon h cross into psi of x. Therefore del psi prime upon del x will be equal to I k upon h cross e raised to I kx upon h cross into psi of x. So we are applying product rule here, plus e raised to I kx upon h cross into d psi upon dx. Now let's multiply by minus I h cross on both sides. Then we get minus I h cross del psi prime upon del x. This is equal to k into e raised to I kx upon h cross del psi by psi of x minus I h cross e raised to I kx upon h cross d psi by dx. Psi prime star is equal to e raised to minus I kx upon h cross psi star x. Now this is equation 1, this is equation 2. Put 1 and 2 in this definition for p prime expectation value. Then you will get p prime expectation value is equal to integral e raised to minus I kx upon h cross psi star x. So this is the psi prime star multiplied by minus I h cross del psi prime upon del x, which is equal to k into e raised to I kx upon h cross psi of x plus minus IH cross e raised to I kx upon h cross d psi by dx into dx. So this is equal to e raised to minus I kx upon h cross into e raised to I kx upon h cross is 1. So what remains is integral k into k comes outside, integral psi star x into psi of x dx, which will be equal to 1 because of orthonormality, plus integral psi star x, here also e raised to minus I kx upon h cross into e raised to I kx upon h cross will give you 1. Minus I h cross d upon dx can be written as momentum operator, because momentum operator is p cap is equal to minus I h cross del by del x into psi of x dx. So p prime expectation value is equal to k plus this integral right here, this thing, this is nothing but the expectation value of momentum. So p prime expectation value is equal to k plus p expectation value. This is the right answer. So when you modify the wave function psi of x to psi prime equal to e raised to I kx upon h cross into psi of x, the expectation value changes from expectation value of p to expectation value of p plus k. So the correct option here is C. This conclusion is the result which can be used in other problems as well. So the conclusion we derived earlier was p prime expectation value is equal to p plus k if psi is changed to psi prime equal to e raised to I kx upon h cross into psi of x. Now there is another property that if psi is real, then expectation value corresponding to psi, expectation value of momentum corresponding to psi will be equal to 0. If you want the proof, it is also very simple. We have p is equal to, expectation value of p is equal to psi real star minus ih cut del by del x psi real dx integral. So here in LHS we have a real quantity, expectation value of momentum cannot be complex, and this is real, this h cut del by del x psi, all of these are real, all of these are real. The only thing that is imaginary is I is imaginary. So if you multiply a real quantity by I, it becomes imaginary. So RHS is imaginary, RHS is imaginary if it is non-zero. If RHS is non-zero, if RHS is non-zero, this is never possible. LHS is real and RHS is imaginary, so RHS must be 0. So from the above two discussions, first discussion is that if we change psi to psi prime equal to e raised to I kx upon h cross psi x, then the new momentum is given by p prime expectation value is equal to expectation value of p plus k. And the second discussion is if psi is real, then expectation value of momentum is 0. From these two discussions, we can conclude that for a wave function of the form e raised to I kx upon h cross into fx, where this fx is real, the expectation value of momentum is equal to k. Expectation value of momentum for a wave function e raised to I kx upon h cross fx, where fx is real, is equal to k. This can be used to solve the problem given here. So the wave function we are given is psi of x equal to sine hyperbolic lambda x exponential minus ax raised to 4 plus bx plus ipx divided by h cross. Let's try to write psi of x as a product of a real function and an exponential term, as we seen earlier. So we have psi of x equal to sine hyperbolic lambda x e raised to minus ax raised to 4 plus bx upon h cross. So this is real function multiplied by e raised to I px upon h cross. Now compare with this earlier format. Compare this with the earlier format. For a wave function of the form e raised to I kx upon h cross fx, where fx is real, we have expectation value of momentum is equal to k. So in our problem here, instead of k we have p. Instead of k we have p here. So expectation value of momentum for this problem will be equal to p. So the correct option here is option B. So this question was from JEST 2023. Now let's go to JEST 2024 question. Here also we have to somehow write the wave function in the earlier form. We have to write the wave function in this form. If we can write the wave function in this form, we will get the expectation value of momentum very easily. So psi of x can be written as psi of x equal to first of all, let us expand the exponent in this term right here in the exponential. So x minus I k naught divided by alpha the whole square. X minus I k naught by alpha the whole square. This is equal to x square plus minus 1 k naught square by alpha square minus 2i k naught by alpha into x. Now when you multiply by minus alpha, you will get minus alpha x square plus k naught square upon alpha plus 2i k naught x. So therefore psi of x can be written as psi of x is equal to exponential of minus alpha x square plus k naught square upon alpha into e raised to 2I k naught x. Now comparing with the earlier format, psi of x equal to real function multiplied by e raised to I kx upon h cross, we see that 2 k naught here is equal to k upon h cross. Or k is equal to 2 h cross k naught. Expectation value of momentum is equal to k is equal to 2 h cross k naught here. So the correct option is option A.